There are a couple of things about mechanical advantage that were hopefully made clear in our previous video where we defined what mechanical advantage is and how it works. And real quick, I wanted to write those things out just for our notes. And the first one is that mechanical advantage is a trade-off. And it's a trade-off of force and distance. And hopefully that was made, like I said, incredibly clear in our last video. Let's widen this out just a little bit. When we say it's a trade-off, we can actually measure that trade-off, what that trade-off is, as it's a ratio or a fraction. We can even write that out. We can say MA is measured as a ratio or fraction. Now, you may have noticed that there were two different ways we found mechanical advantage in our previous video. And what I hope to do, or hope to accomplish with this video, is explaining sort of those two types of mechanical advantage. In fact, let's go ahead and write that out. There are two different types of mechanical advantage, two different MAs, we'll say for short, and both are based on effort. And go ahead and widen this out. We'll say effort, or E, and resistance, or let's widen this out just a little bit more, or R. And to explain the two different ways to calculate mechanical advantage, let's go ahead and look at another example of an inclined plane. So let's go ahead and draw ourselves another inclined plane here, and let's draw the platform at the top and this height. And let's say that height, the height of this inclined plane, the total height is just 3 feet. And let's say the distance traveled by this, and the distance of the ramp itself, I should say, would be the distance we would travel if we used the machine, is 15 feet. Okay, and this time, let's say we have a weight of 100 pounds. We have some, let's call it a box that's 100 pounds, and that's 100 pounds straight down. That is not the same as the force we would apply upward, right? If we were, let's go ahead and draw a person pushing this box up the incline here. But that would not be the same force. And what that force would be, I mean, assuming that everything is equal and we're in a frictionless world, which we're not. But if you do the math real quick, you can see that, well, this is 5 times bigger than this, so this will be 5 times bigger. So we could say that the force that would take to push it up this ramp would be 20 pounds. And if you can't do that in your head or you don't understand how I got that, you can just trust me. You'll see how it's 20 pounds, hopefully, by the end of the video. You can just trust me on the math here so we can move on. But let's say this is our scenario. Now, using this example, let's go ahead and define or lay out the two different types of mechanical advantage. And the first one is the actual mechanical advantage, which is the mechanical advantage you would see in the real world, or AMA for short. And the second type of mechanical advantage is the ideal mechanical advantage, or the mechanical advantage you would see in a perfect world, and we'll go ahead and call that IMA for short. Now, it's important to note that in the real world, or the actual world, we don't see these two as the same thing. Friction affects the system and lowers the ideal mechanical advantage to the actual, but for now, to make our life simple, we will assume a frictionless world, and therefore ideal mechanical advantage and actual mechanical advantage are the same thing. In future videos, we'll discuss the differences and how to calculate them and why those differences are important, but for now, let's move on. And as we said a minute ago, they are both based on effort and resistance, but the actual mechanical advantage is based on force effort and force resistance. So let's say based on force. Whereas the ideal mechanical advantage is based on distance. And so what are we talking about? Okay, let's go ahead and actually write out the equation for AMA and IMA. So let's go ahead and grab we'll use red for now for AMA since we wrote out AMA as, keep our colors consistent here. Let's say that AMA equals, and what does it equal? It's a ratio, we know that, or it's a fraction, we've said. So we can go ahead and write it as a fraction, and we'll say that it is, what color do we use for resistance? It is our FR, our force resistance, divided by our, we use pink for effort, divided by our force effort. And you might ask yourself, well, what are these two numbers? Well, we have two forces in the system, the force we use to get it up there and the actual weight. And hopefully it's incredibly obvious which one would be your effort and which one would be your resistance. But if it's not, let's go ahead and talk about it. The effort force, or the FE, would be the force we apply to our system or our machine. So that would be the 20 pounds it would take to push it up. So we'll call that force, effort, or FE. Now, the 100-pound weight would be the weight we are trying to overcome, or the resistance, otherwise known as our force resistance, or FR. And so we can actually now, we can just plug those numbers in. We could say, well, FR over FE, we just said FR is 100 pounds. And we can divide that by 20 pounds, which is our FE. And so what do we get? Well, we get 100, well, let's go ahead and cancel out pounds. 100 divided by 20 is just 5 over 1. Or we could say that it is a 5-to-1 ratio, or we could just say there's a mechanical advantage of 5. And it's important to note that it is a ratio, because when it's a ratio, that means our units cancel out and we're left with no units for mechanical advantage. Now, what about the ideal mechanical advantage? And we use green for that. Let's go ahead and keep that up. Well, the ideal mechanical advantage, or the IMA, that equals our distance effort divided by our distance resistance. And so here we got to recognize, well, what is our distance effort and what is our distance resistance? Well, the distance effort is the effort, or the distance we apply our effort force, which would be this 15 feet. That's where we would apply our effort force. That's the machine, the effort we're using with our inclined plane. Whereas the resistance would be the distance we are trying to overcome using our machine. And so we're trying to make this box go up 3 feet using this 15-foot distance effort. So this 3 feet would clearly be our distance resistance. And so we can go ahead and plug that in here. We say our distance effort is 15 feet. And our distance resistance is 3 feet. And again, we divide these, feet cancels out, and 15 divided by 3 is a mechanical advantage of 5. And so you might be looking at these equations and you might say it's a little confusing, right? We'd say that the IMA equals DE over DR, whereas the AMA equals FR over FE. Over here we got E over R, here we have R over E. And how do I distinguish between these two formulas? How do I memorize this? IMA, the ideal mechanical advantage, equals the distance effort over the distance resistance. Well, I actually have a kind of a fun way, or I don't know, fun way, but I have a way that rolls off the tongue pretty well, pretty easy to remember these equations, and that is, well, I look at this IMA. What I think when I see the term IMA, I think I'm A. Like sentence, starting a sentence, I'm A, and you're calling yourself something. And we say, okay, DE over DR. I say, it looks like I'm a deer. And really, it looks more like Dieter, right? DE over DR, Dieter. But I'm a deer obviously rolls off the tongue better. And if you say it this way, you recognize that E goes before R, or I should say more correctly, E goes over R. So if you just remember I'm a deer, you remember your IMA equation. And now as for the AMA equation, I have a similar expression. So when I see AMA, I see am, and we'll say So think of it like amma, like think about how a country singer would say the phrase am I. And we'd say, okay, FR over FE, I would say free. And so now, and again, it would be freffe, right? But free rolls off the tongue better. It's an actual word, whereas freffe isn't. But we say this like a country singer would say it. So you say, am I free? And you can go ahead and say it to yourself and practice yourself. It's kind of fun. Say, am I free? And I mean, yeah, it just kind of helps you remember it. Am I free and I'm a deer? It helps you remember the two equations because it's R before E, therefore R is over E, and hopefully it'll help you remember. It's not FE over FR, so it's not am a fear, right? And it's not I'm a Dre, and then it's obviously not I'm a free and am I a deer? That doesn't make any sense, right? We all know you're not a deer. So if you think about these equations as these two phrases, hopefully it'll help you memorize these phrases. And don't worry, these two phrases will be thrown at you quite often over the next few weeks and the next few lessons. So hopefully it'll be really easy to remember.